Hi, welcome to Expert Talks at Mavericks. This is the interview series with thought leaders in the AI, analytics, and transformation space. My name is Mahadevann Iyerr, Mahaa for short. I'm your host for today. I'm the co-founder and CEO of Mavericks, which is a managed marketplace for on-demand analytics and business transformation services. Our guest for today is Mathangi Sri Ramachandran. Mathangi is the Chief Data Officer at YUBI. Prior to UB, Mathangi led data science functions at GoJek or the GoFood part of GoJek. She also led data science at PhonePe. She's had a stellar career spanning nearly 2 decades in data sciences across multiple organizations. She holds more than 100 plus patents. She's the author of 2 books. She's also recognized among the top 50 influential AI leaders in India. So, Mathangi, thank you so much for making time to talk to us at Expert Talks at Mavericks. I'm looking forward to the conversation.
Thanks a lot, Maha. I think it's going to be a great conversation. Thanks. We'll talk further on this.
Okay, excellent. So my first thing is, you obviously started off with 24 by, or you worked in 24/7 for almost 8 years, which is a services organization helping clients. You worked with Citibank, one of the largest MNC banks, right? And then PhonePe in the digital wallet and financial services app platform business. GoFood, which like you said, is a Swiggy equivalent in the on-demand consumer services platform, and now with UBI, which is essentially, as I understand, one of the largest corporate debt platforms, enabling financial services across lenders, borrowers, and investors, right? So what I wanted to understand from you is 2 things. One is if you can give us a little more sense of what UB is for some of our listeners to understand a little better. And then, while this is a lot of it is in the financial services part, but they span the consumer side of it, the enterprise side of it. You have also been in the services space with GoJek and GoFood. So how do you go about? And I also listened to one of your interviews, and I think I read a blog where you spoke about the importance of context for a data scientist to be, really be successful and create impact, right? So, given this type of companies and organizations that you have worked for, right, what are some of your approaches to building domain knowledge and contextual awareness for yourself and also for your team?
Sure, thanks, Maha. So I'll answer the first question. I'll address what is UBI. UBI is a financial lending infrastructure that we're building for the country. We have on one side, you could think this as a marketplace where there are enterprise borrowers and then there are lenders. But how do you make these matchmakings better for better financial transaction and hence improve overall efficiency of this process? On the other side, we also are a collection platform. We kind of help banks do collections that are not only efficient but also have a high customer experience component to it. So we do the end-to-end journey of a loan origination till it gets collected back, but we are the infrastructure for this. So that's what UBI is, and at UBI data plays front and center to all of the data driven, all of the decision making, and most of the decisions are data driven. And by doing that, we are helping our customers to have more transparent decision making at one point and making it extremely data driven. So they can also see what are the results, what are the estimates of taking path A versus path B through data. And we believe through this process, there will be better financial inclusion in the country, making money reach the right pools of needs at the right price points also. So that's the overall picture of UBI. Now I'll shift gears and come to your question on context and what is the role context plays in data science. So this has been my experience in working in this field. So I started out as an analyst and then was very statistically oriented, building models which are deep statistical models, but also could had high explainability. From there, moved to field of computer science, which I kind of learned it on the job, building natural language processing models to start with, democratizing natural language processing so that those tools can be used by somebody in call center also. So not only did we build some of these models, but also build products out of it, to pockets which can leverage it on their own. That has been my core theme of career also. One is to create impacts. Second is how do we make self-serve engines that can reach pockets and increase the scale of usage, right? So coming back on both these aspects, context is extremely important. So without context, they are just algorithms and numbers and libraries and codes, which may or may not solve a problem, right? So and for a long time, the industry I think made a mistake was that we were going behind people who were experts in, let's say, certain set of algorithms, who understand the math very well, but they were not able to convert that mathematical problem or match the mathematical problem to a business context. So context was somewhere, application was somewhere, huge gap. And even on problems like text mining, etc., right? So there was I'll take an example from my life experience, right? So there was a problem where we had to find out what are some of the topics that customers talk when they talk to a call center, right? When they talk to a chat center, for example. So you have millions of chat corpus. What are top things that the customers are discussing about? Now, the way the word topics get formed, that immediately there are topic models and clusters, etc. That happened, and these are large lines of chat data. So there could be 25, 30 lines of chat data on an average, and it's a conversation. So it's agent, customer kind of format. From here to mine, what was it about? You need to kind of do some level of data understanding, some level of understanding what the business is about, context is about, then kind of zero down on the area of interest, then get into text mining techniques, right? So that's how this should have ideally worked, but a lot of people were trying this very differently. They were taking the entire chat corpus, throwing it into a clustering algorithm, or throwing this into a topic modeling algorithm, and trying to get some solutions which wasn't answering a business purpose, right? So even things like this, which when I say this, even to me it sounds very obvious, like why would somebody take the entire data corpus and throw it in a machine? But this was happening. And even now, data scientists do make these mistakes of not waiting enough for the problem to be formed, not going with the person who has the problem and understand from them what is the problem before starting to build anything, right? Crux of this is crux of what we face largely, and why AI is considered a black box, why a lot of people still don't build AI teams in their organization, is because of they don't know, right, whether this will have an impact or not, and more often than not the impact doesn't come. So for various reasons, etc. And one of the core reasons I feel is also squarely rests with the data science teams, where people don't sit enough on the business problem, understand where the issue is, then try to solve something rather than solving it like what I would call a hackathon. So it's very important to understand context, and that makes a large difference. Of course, algorithms are important, the math is important, writing codes that can run faster are important, deploying your models are important, but all of that can be important only if the solution of the problem is right. And that's where, especially with the first time problem, 60 to 70% of that entire effort has to be context, has to be so to say, interviews with the stakeholders, interviews with the person who's having the actual problem, and then solve it for. In cases where you really cannot, if it's an end consumer, you don't have access, again there are mechanisms to understand what is needed before you, start solving the problem. And you develop this over a period of time. You develop this through experiences by solving variety of problems. You develop this by working across multiple organizations. Being empathetic to the end user while solving a problem is extremely important, and that shows up in the solution.
No, absolutely. Very well put. I think empathy for the end user, empathy for the business, empathy for the consumer is almost like you said, the start point for a data scientist to be able to really, talk to the business, understand more about their problem. It actually helps. Sometimes I feel the best hypothesis actually comes from the business, where business users are able to help articulate the hypothesis around which you want to really really validate your solutions or take the first few input factors, so to say, right? And in my experience, I've also had situations where we have looked at hypotheses and also looked at solutions, and many cases the solution had inputs where the factors were not controllable, right? And so what do you do with those? The business would say, okay, this is great, but I don't control this, right? Um, for example, if you're a retail, the type of the family makeup life stage of the customer that is coming in over a period of time you can control. But on the immediate level, if it's a family coming in, if they have two girls or two boys or one boy, one girl, the business doesn't control it, right? So when you say, if you had this profile of customers walking in, it's
Correct.
great to say, but you don't control that. Then the business
Yeah.
says, okay, this is theoretical, but
Correct.
I don't know when I'll practically implement it, type of stuff.
Yeah. Right. Right.
Great. So you made another interesting point about, when we're talking of your experience, which is about democratizing usage, right? So, which essentially means like building the platform not only to solve a problem, but enabling the business end users to also take self-help through, I'm assuming you build low-code platforms or no-code platforms for them to do it, right? And a large portion of that is also about understanding the UI and UX around it broadly. I don't want to make it too theoretical, but the business or the user has to have a comfort about using it, right?
Correct.
Um, how much of effort do you think, typically a data science team should spend on that particular part of it? You spoke of the context part of it. Now, the delivery part of it is where you need it to be a lot more usable, for lack of better word. So, how do you go about that?
I think, see, finally, data is an asset of the organization.
Hmm,
The data does not belong to a team. Data is not a team; it's an asset.
hmm,
So today, anything in data, people think, okay, data team will solve it, right? It's not that. Data,
hmm,
if data is gets restricted to only the data team, then the democratization and large scale decision making does not happen.
hmm,
So I think, however the team starts, and depending on the life cycle of wherever the team is, the angle that this team should take is they start owning a lot of infrastructure components about it and build an application layer with UX, UI, depending on how friendly the users are with technology. You build an application layer and you democratize these components so that each on their own, right? So then you don't get preachy with your analysis and actions and everything. See, it's not happening otherwise, right? So I can have an analysis, I can put out action items, I can be more an internal consultant team to other parts, but they have their own speed of working. They understand the markets very differently from what you understand. Their slice and dices are very different from what you would do. How everyone visualizes data, how they perceive certain things are very judgmental, right? And you can't take that out of a function. You can't say we will understand all the hypotheses, put them in one barrel, and then give you dashboards and reports, for example. That's not going to work because those hypotheses are themselves going to change, and there are going to be multiple business users. Each of them will have their own variety and cut to look at data. So, in which case, how do you democratize this? How do you make sure that I become an infrastructure for you and I am accountable so that you can make decisions at scale? And I will kind of distance myself more and more away from what your exact decision is, but I will become more accountable so that you can make those decisions much faster and more data driven than you would have made. Right? That would be a scalable approach. Now that I gave you an example so again, let me classify decisions into two parts, right? One is human-led, machine-assisted, right? That data assisted. The other part would be data-led, human-governed. So I'm talking about the first part when I'm largely talking about democratization, which is human-led, data-assisted. So then data plays an assistance role, enable infrastructure, but make sure that default people come to it, right? Default people come to those systems to churn out the decisions. So the example I talked about, we deployed this in, in 247.ai with the call center folks, where they were able to use our products on natural language processing. They were able to feed the data, get insights, build their own models, take their own decisions. So it's an end-to-end platform of text mining, kind of a modeling workbench that got, to them, it gives them a lot of control, gives them some bit of learning also, but largely decouples the dependency on a central team.
Hmm.
And you're not again sprouting data scientists in each of the teams. So that's not the setup I'm recommending. I'm saying build an infrastructure such that your end users who are day to day making decisions have a decision assist from your platform. That's one. The other part of the story is possibly falls a lot within the data team is the machine led and human governed, right? And there, the human governance piece again cannot come only from folks within the data organization, right? That the governance of how that solution look like, what are the guardrails, what is the North Star, what are the experiments you are going to set up, how do you replace a legacy decisioning engine with a expert machine learned decisioning engine. All of these are discussions that you need to have. The governance of the solution, right? Be it about A/B tests, or be it about what are you measuring, what are your core metric, what's your baseline metric, what's your constraint metric, etc. Is a discussion, is a collaboration, so to say, between data and the stakeholders on this. Right? That's how you build the machine-led, human-governed systems. So, and definitely in the first part, building platforms, self-serve platforms becomes very important. Again, that need not be only for internal users. We are also building, for example, in UBI, our data platform is called as UBIT. And one of the things that we are offering, especially when it comes to enterprise risk management scores, etc., we are coming with a solution where we'll give them as a workbench to the end users, to the customers, to the analysts in the bank, and then they can, add to the existing model. They can have control on the model parameters. They can build their own models. Right? But again, the infrastructure is very algorithmic, is intelligence, is intense to that domain. So that's where we come in. I think that angle would work to scale so much more better than the keys to the kingdom always being with the analyst, in which sense even you staff, so even if you double it, triple it, 10 times staff, data driven decisioning will not be truly achieved, and people within the data will not see a career path because see they're just throwing out some analysis in some consultation mode, which is not where they are driving the impact, right? So I think that could be the future, on self-service, on taking data to be used and well adopted across the organization within and outside.
Oh, nicely put. So one of the questions I wanted to ask, in the way you answered that, is, how does the analytics organization balance between quick turnaround analytics, which is actually trying to solve the immediacy of business problem, and typically strategic breakthrough models or initiatives, which is a little more long-term focused, right? I don't know if I'm trying to oversimplify this, but my own, the way I'm seeing it in my mind is anything which is, human-led and machine-assisted, where you're giving self-serve models, is where business can actually have data access to it in an intelligent and usable format and take their own decisions to respond quickly to business exigencies and immediacies, right? Whereas the one which is essentially machine-led and human-governed is where you're actually building a lot more of breakthrough models, more strategic, slightly long term. And in both cases, like you're saying, at the end of it, one in terms of usability, other in terms of governance, you are essentially giving the keys to the kingdom, as you said, to the business users and letting it actually make AI and the analytics team a lot more business relevant. Have I understood it right?
Correct, you have understood it right.
Okay, excellent. Okay. Now, so obviously, we will talk of what it takes to have a great data science team and create impact. But before that, I want to ask about what are some of the organizational ecosystem enablers, which are important. So you worked across various organizations, right? Assuming for a minute that the data science capability and understanding was at the same level, right? I still feel, a data science team makes different level of impact depending on the organizations which it is housed, right? Uh, so just your thoughts on, how do ecosystem enablers, like, for example, organizational culture, maybe data maturity, leadership focus, the business itself, right? In terms of, what is the like retail, you have to almost, it's a daily job literally, right? In grocery, it is even more higher than in fashion, where you have a little more involved, right? Or B2B businesses, where maybe the business cycle and the frequency can be little, so there is a level of time available for a business to respond. In some cases, the response has to be very fast. Some it can have a little more time. So, various business parameters are there about the ecosystem enablers, right? So your own feel about, what are some of those organization enablers which are which almost drive the success of a data science function?
Yeah, so one of the things that I have addressed in many of my talks is that for data science to work and create an impact, three things are needed. One is the data, right? You have to have quantum of data to make sciences out of it. Otherwise, if it's small data, largely you can make it through rules and expert systems. Second is the problems. There should be problems that kind of as an optimization constraint. The constrained problems have to be there. Right? So if I have, for example, if I have a 1 crore budget, right? And that means I have to give like some 10% off to all my customers, let's say 1,000 customers. And if I give 10% off, it will anyway cover based on historic data the 1 crore budget. I don't need to pick any customer, right? I can exhaust my budget. So there has to be meaningful constraints that data science can solve.
Well,
That's number two. Number three, and the most important thing also is organization culture, right? And what does this organization culture comprise of? It comprises of a nature to experiment, right? First and foremost, they need to have a paradigm to move away from deterministic outputs to a probabilistic output. So that has to be well understood, well accepted, because any solution, somebody is taking a call to put it out there, right? Somebody is signing up on the risk. So the culture of experimentation has to be there. From, of course, any culture flows from the top. So the culture of experimentation starts with the founder or the CEO and then kind of percolates to their next leadership and so on. That's one big thing, right? The culture to accept that follows in a way, the culture to accept failures is also very, very important, right? So I often tell my team that if we run 100 projects and if all the 100 projects or 95 projects of them succeed, then we have not done one thing well. We have not kind of experimented enough. We have not taken larger bets. We are taking smaller bets. We are making incremental changes, and to make incremental changes, we may or may not even be required. Right? So there's a reason why a data team becomes a strategic importance to the company, and that it is to make non-linear impacts. Data team sits and makes linear impacts, right? So that kind of on the outset there can be reasons to it, but at the outset it looks something to probe further. So if out of 100 projects 95 succeed, there's something really really problematic about it. Either you're not taking enough bets, or you're kind of doing some linear improvements. So that's number two. So following experimentation, an important thing is the ability to kind of fail, right? And kind of take the failure and accept failure as a way of functioning, failure as the means to move to the next step. That's important for the organization. The third thing is also about moving away from an expert systems kind of mindset, right? Like I know it all. To I want to see what it is saying. I'm willing to be proven wrong with data. Right? I would call it that way. That is also very, very important. And again, this cannot be only with the CEO or founder, but has to be with the CEO and founder, but also with all the business teams, also with the product teams, where they are humble enough to be proven wrong and expecting it to be proven wrong with data.
Data.
Those I think could define the culture of a data-driven organization. Now, if this is there, right, this is all we need. We don't need people who understand AI, people who have kind of learned some courses on AI, or people who have worked with data science team in the past. Even that may not be needed. If these three things are there, then it becomes the data leader's heart and soul responsibility to make sure that data driven decisions thrive there, right? So, but if these three are not there, it's going to be very difficult for anyone to come in and make a difference, because these are very behavioral, cultural aspects of an organization. But if these three are there, then they could kind of get there and start things from scratch. Even if nothing on data is there, they can build a castle in them. I'll repeat those three things. One is the ability to experiment, ability to fail, ability to be proven wrong.
No, excellently put. Does this change with the life stage of a company? Or Citibank, which is, I don't know, 100-year-old organization, possibly a PhonePe, a startup, maybe a GoJek, a young company, for lack of a better word, UBI, new age disruptor, right? Different life stages of the organization, right? And you have worked across, some of them very early, some of them a little more established, some of them, like a 100-year-old company. Does life stage have anything to do? Do you feel that in a young company, these ecosystem enablers you spoke about, its ability to experiment, fail, and get proven wrong, is far higher than an established company, or vice versa? Any thoughts on that, or you think it doesn't matter?
I see one. I have chosen companies only when if these three things are right, right.
Okay.
So
Okay.
it's
Okay.
also how I select organizations to work with.
Okay.
Having said that, while kind of speaking to different organizations in different forums and things like that, and also talking to network friends and leadership in these different organizations, I am not able to predict a pattern here in terms of years of the companies to a data driven culture, right? I think the culture does come from the top, right? On this
Okay.
particular thing, I always think this culture comes from the top, sustained by the people at the bottom, right? That's how
Mm.
it is. Once you set the culture and you stand for it, then the culture becomes so pronounced with the large amount of people in the organization. Then even if the founder makes a culture shift, the people at the bottom are able to form an opinion that you are not following the culture,
Mm.
and then various things can happen. But setting the ball rolling starts from the top, and hence there can be large organizations. I've heard
Mm.
of them where they are very deterministic, risk averse organizations right now, and they have a certain way of executing. They will use data definitely, because I don't think there is any organization today at a certain level of performance and profitability can afford not to have data in their kitty. But what is the strategic importance of data makes a difference. Now that you can have large, yeah, organizations which also the markets are celebrating may not have a strategic view of data. They may still use data. They may use a lot of data assist. They may use data in tactical ways, etc. But may not be their primary driver of growth. I am talking about primary driver of growth, where it will make that difference, is when those three traits does apply to the founding team, their top management, and so on. So
Got it.
yeah.
Got it. Now, you use the word deterministic and probabilistic, right? So again, my understanding is when you're saying deterministic, you're essentially saying typically deterministic is taken where it is a little more risk averse, and people know that you're operating within guardrail and things may not go wrong, if you operate within that. Whereas probabilistic is where you're saying that, you're giving a large canvas for them to take bets, right? And possibly strategic non-linear impact can happen because of problem input that is being given. And like you said, that requires a culture of both experimentation and ability, not only for the data science time, for the business also to take failures.
Correct.
Is that how you look at it?
Yeah, that's how I look at it. See, when I meant deterministic, some people want to feel the output, right? Like feel why the output is there. They want to understand why certain thing happened at every minute level, right?
Hmm.
So one, the output itself, hence they resort to deterministic, right? In
Hmm.
probabilistic output, the explainability may also be very limited.
Hmm.
In deterministic output, you are only determining the output, so there's nothing to explain, right?
Hmm. Hmm.
So, for example, let's say I'm running a restaurant, and every time it rains, I'm going to give it 20% off, right? So
Hmm.
that will buy my pakoras. Let's say this is a very simple
Hmm.
example.
Hmm.
Now, what is non-explainable in it? Every time it rains, and we 20% off. The question comes, why 20% off? Do you think giving 20% off will make people buy more pakoras, or you're giving 20% off to people who would have anyway bought your pakoras, right? And after the rain, does it even make a difference? Or if you predict before the rain it's going to rain and start giving the pakoda so that they get into the mindset of planning their evening snack. Now there lies the difference a data science can make. Now to accept this hypothesis and to say, okay, I'm going to try this out, is the mindset I'm talking about. But while doing it, you don't know this. One, there's an unknown science coming in. One, the question is, how does it matter to me as I have some budget to burn for the pakoda, so I'm okay with that. So if these are the things you keep reasoning yourself, you are still in a mode in which you want to control the complete output at the cost of even growth, for example, or at the cost of um,
Profitability for.
profitability also. That is what I'm mainly meaning as deterministic outputs.
No, this is clear. Thank you. Thank you for clarifying that. Now, so one of the my own learnings has been while we had, both in Landmark and in Tesco, we had humongous amount of internal data or first party data, for lack of better word, right? Consumer data, buying patterns, and all that type of stuff, right? Um, but as we started getting more and more closer to the business to start creating value, right? One of the realizations was all this internal data is good, but if you're not able to apply a external perspective onto that, it is just about that, right? And I again, in one of your YouTube videos, I think you spoke of alternate data sources. And my understanding, you mean secondary data sources, right? Which is what is out there in the universe, in the market, whatever on the internet, and then or other sources, and then how do you bring it in, right? Um, so if you could just expand a little more on the importance of alternate data for a data scientist to really be able to contextualize a problem a lot better, and some examples of such sources of data.
Sure. So alternate data sources today are largely used in scores. So when moment people think alternate data, they think also structured data that playing a role about extra signals about the customer, which is not kind of coming in the core DB. And can you use that to make decisioning better? We do have a platform for that. But that aside, using alternate data has been one of the kind of path breakers in text mining problems. I'll give you an example again. When we were trying to work on named entity recognitions, let's say we had this problem. We wanted to match Samsung refrigerator 20 liters to Samsung refrigerator as a category, right? Like something like that. Now, or Samsung 20-liter with freezer or some description is given, and you want to match it to the category of Samsung refrigerators. One way is just to use the words, whatever is there, and then do a similarity match. Next step itself is semantic similarity, right? Samsung is associated with X things. The word, let's say Samsung 20-liter with freezer is associated with so many things. Similarly, on the other side, you do expansion. the category refrigerator is associated with so many things. Now you do matches. Right? So this, in this step itself, you are bringing external data in it, because that's how you are expanding. The next level of it is kind of go to the internet and see what search results you're getting for your Samsung 20-liter freezer. Then you see what search results you're getting for Samsung refrigerator as results, and then you do results to results similarity, right? So you have now kind of brought in, so to say, alternate data in it. And this has been practiced, and this kind of paradigms really makes a huge difference in language processing. And even in problems like named entity recognition, where you are matching, you don't stick to words. You stick to words and see, then you stick to semantic meanings of this and see. I went to one ice cream shop and I went to buy something, right? Are similar in a space because both are about shopping, correct? Now that is meaning wise similarity. Then the next level is about getting more context into each of the word, just expanding the query term, as they call query expansion, in both sides, and then matching it. This became a big factor, and a lot of name entity recognitions were not just restricted to just the names or the words in it, but ended up expanding the universe for matching. And NER still continues to be a problem today, because named entities can absolutely depend on a localized context, right? So India as an NER may be easily classifiable as a country, but let us say some local college, right? Let's say Sarojini College of Engineering and Technology is very local to that space, right? Now, how do you classify this as a institute, other than using the words College of Engineering and Technology? Those kind of questions come in, and I think language processing kind of started using alternate data, quote unquote, for its mechanism long back. And then that translated into transfer learnings, that translated into language models, and what we are seeing with ChatGPT and everything. That's actually bringing the context outside to inside. Right? That's how those models are taught. Language models in themselves are nothing but world context about a word, world context about a sentence. And then you apply your world context on the set of local context you have, and then there you go, you have a very powerful algorithm at play. Very, very effectively used in language for a large extent, definitely used in vision now, big time. And structured data is kind of getting into that space. I'll give you another example. Example that I keep living with. That's why I'm very passionate about this topic alone. So in structured data, there is both your numerical values like rainfall, what is a centimeter, etc., and all of that. Then there are categorical values. So city is a categorical value, and very classic way of handling city is you bucket city into metros, non-metros, tier 1, tier 2, tier 3. Very that's also, if you see, getting context there, right? But there can be unusual way of doing it. What we can do is you take city, you can go to Wikipedia, get population of the city and all of that, and scrape that and expand that city into 10 numerical parameters, and then train your model on it. So that is also using alternate data into it, right? Or name, I'm very passionate about the variable name and what it can provide insights, right? Name can provide information about geography of the person. Could provide information in some cases about the language of the person, because we take surname. If you go to Middle East and where this cosmopolitan population, then it can provide ethnicity of the person. How do you match name to an ethnicity is also something very interesting. Of course, all of this under the guidelines of AI and ethics in AI, etc. But I'm just saying, from a technical perspective, alternate data does not only need to mean a source of social signals about the customer outside. It could also mean publicly available information about certain subcategories of information that is there in structured data also.
Very nice, and very nicely explained. For many people like me, it is numeric data about when you do scoring for a consumer, right? You look at a few things in terms of data availability about that particular person, right? And maybe, like you said, you don't go beyond expanding it into the on the name from the location that they operate. Sometimes, in terms of while we talk of a lot of these social media mentions and triggers and likes and all that, have you ever used this in terms of people responding on social media, their comments and all that, and to get a lot more of external perspective about a consumer or a business or whatever?
We have done many projects as the Twitter mentions of about a company, the profile of this. Now at UB we have public data available about a lot of corporates. So we are building our products where companies can make credit decisioning out of the information that's there in public data. We are going to the level of the videos of the companies, the analyst views of the companies, what they are saying, what are the body languages, tons of cue that can be, crafted with the information that is available publicly outside the company. So you're not compromising anything to make recommendations about the company, to make a matchmaking for that company with an investor, or to kind of say yes or no kind of decision.
Nice. So now, so one of the the great things about AI and the ability to process data from multiple sources, structured, unstructured, etc., uh, is obviously, the more you train data, the more number of features you put into it and you fine tune them, the level of prediction accuracy tends to increase, right? But the flip side of that is essentially like with a decision tree, your explainability can be high, your level of accuracy could be low. With a deep learning model, your accuracy could be high, but there are struggles about how you do explainability, right? And the world is moving where it wants both, right? One wants to have the cake and eat it too, right? I want business wants uh, you know decisions with a lot of confidence level, high level of predictability, and the decision being right. Equally, the environment warrants that there needs to be a level of explainability so that the end user can understand the reason behind the decision. Why did you give me a loan and not give me a loan, type of stuff, right? Um, so I mean, obviously, there are explainable AI is being spoken about a lot more. But any practical examples of this, or is there a balance where you think some places it needs to be applied, some places it is not relevant? How do you?
See, explainability has to be there, but with some level of pinch of salt, right? Now, I'm for some reason I'm going to the rainfall example again. So let's say we
Okay.
are predicting is it going to rain today in Bangalore, right? Now you are interested in the prediction accuracy. You want to know whether it's going to rain so that you have prepared yourself. Now, how much can you, what, even if I put a linear model out, the people have, see, I think somewhere the trade off is between explainability and convenience, right? So, if I put a linear model, I can understand the weights on humidity, weights on, yesterday's rainfall or not, or weights on wind speed and things like that, right? And then it becomes, let's say, I know sciences of weather very well, then I can kind of relate to this and say this is correct or this is not correct. That is one type of explainability. Right. Now, if you look at causation, now can even with those weights, can you see when the wind speed increases, the probability of rain is low or high or anything? Now, when it comes to that point of causation, let me take a better example to explain causation, right? So sales are going up, and the sales are going up for various reasons. It's festival season. Suddenly the economy has boomed back, or the product price had gone down. One competitor has got shut down. Government has bring up some policy which favors this product, etc. Now, all of these, even in a linear model, you can give a lot of weights to it. But can you exactly say what caused, what is that exact thing that caused the sales to high or low? It becomes at that point a very philosophical question.
Correct.
Causation for anything is so hard to explain. They don't even do it in medical sciences, right? Where the patient is more dying of why it happened to me than about the fact that something happened to me, right?
Hmm. Hmm.
Right? In
Correct.
an
Correct.
illness, I think what kills people more is why me than the illness itself, right?
Correct.
So even there, they refrain from telling you why it happened. Maybe it's a set of some unfortunate events that has led to this. Which of those events, we don't know that, right? So it becomes, unfortunately, it becomes a philosophical question from a business question. When you start opening the lid of causation, why sales are high? Why are more people leaving my organization? It's a multi-factor interaction,
Related.
interrelated variables with heavy interactions among themselves. And how would you pin down a cause? Right. So that to me is a rabbit hole if not well exercised. So the trade-off hence has to be well done, right? So you're getting a certain level of prediction, and with that prediction, you want to take an action, and you understand to some level what the model is. You're good to go, in my opinion, right? If you get to that level of I am okay to compromise my accuracy, but I want a linear model because I'm very, despite data showing non-linearity, despite data showing interaction variables, despite data showing interrelated variables, right? So you are kind of despite that you are saying I'm okay with the lower accuracy, but I want the models that I can understand. I don't know what is the sense in that perspective, from that perspective, right? You are still not explaining randomness fully. You are going with a model that is less explaining the variations than a model that is more explaining the variations, just because you can understand model A better personally than model B. That is a trade-off that people need to exercise and look at why they need the model in the first place, and then take the call. So if I can reduce defaults by 2% for the company by going into a non-linear model, but to some level explainable, but then I'm making a choice, I'll go with a model that has ending up to be a 5% default rate. I'm losing more money. I'm kind of not bringing back the money back to the pool of disbursement. So, but I'm still doing it because that's more linear. That's a question regulators need to ask, that a question governance bodies and organizations need to ask, that a question head of businesses, head of data needs to ask, is that the right trade-off to make?
Absolutely agree. Yeah, sometimes it could also be like wherever a data is impacting a end user or a consumer. For example, where there is a human feeling involved, maybe you need a lot more explainability. Where eventually a decision which doesn't really straight away directly impact or is visible to the end user, maybe a less explainable but more accurate model could possibly work, right? Maybe that could be some trade-offs there.
But this field also has grown, right? So the field of explainability also has grown. So you can now do row level explanations, right? Why did we decline your credit card? Can be explained. Now, can that be explained to a level that it's completely satisfying? May not be, right? Maybe somebody lost a job recently and hence their credit score started falling, and because of which their over limit came down, and hence they kind of drew more from another card. Let us say this is the whole actual happening. If at all somebody were to, you might end up saying that you defaulted in two cards. That's all you will say. You cannot say and a loss of job can be shown as another factor, right? But one led to another, and they are interdependent and stuff like that will not come out there. There also, it's definitely advanced at this level. Even for neural network models, the explainability part of it has evolved and should keep evolving as well, because we need to have an understanding of governance of the model more than anything else, because you don't want to have variables which are kind of latent variables to something else that you should not have been part of the model, things like that. But other than that, there are ways to say, there are ways to even provide a user experience with the right explainability in it. The trade-off has to be very clear, right? If the trade-off is about, I have a policy, I'm adhering to that policy, and that policy tells me that only variables which are kind of moving in monotonic directions with my dependent variable can be approved. Those are the paradigms that model reviews, reviewing councils, the MRMs in banks have to start questioning.
Got it. So one of your blogs I read about where you spoke about this thing on transfer learning. You said there are models that you could try and bring into organization, but I thought your comfort was about trying to see if the organization can build its own model, because you said entropy is the reality of business. And if you have the models which are uh, developed in-house, not really dependent on external models, then your ability to respond to the business and create value based on the change that the business is seeing can be far higher, or can be far agile, for lack of a better word, right? Can you just expand on that a little more?
So, see, interestingly, we started the discussion with this, right? We said it's about context. It's about context, fine tuning, and optimization. That's what I think data science is about. Now, and the more you have a context about a local problem, the better you would do good in locally beating the baselines and everything. Of course, you need to have you. It should make sense for you to apply a local model there. That's a part. So, and then optimizing that, looking. So when you do optimization, you're setting experiments. You're saying, okay, I set this experiment. I built a model A, which was very specific to the local context. I might have taken some level of transfer learning, but then modified it to my situation using fine tuning. And then I have done my first set of model. Now I'm getting feedback, and then how I am on the loop optimizing it determines definitely better results than what I would have taken a global model. One example is, so language models are very prevalent there. There are the big companies, big tech companies, kind of constantly releasing language models. We are of course leveraging some of that, etc. But one gap it's coming out is for Indian languages, Indian dialects, way a farmer in India speaks with where they could combine multiple languages. Their way of pronouncing certain words may not be well captured, even if the language model has supports certain Indian languages, right? One reason is these data is not just available in the internet. Internet is absolutely flooded with English, which is spoken with a small set of people across the globe, right? So those are where fine tuning as well as applying for that context will give a tremendous edge. I think that, and then you're setting experiments, and then you're seeing how your people react, and then you're constantly optimizing it. I think that is also the big piece of the puzzle that will make you, let's say, an out of the box is giving you 85% accuracy, but you want it to 95, 97%, you want to get it. That edge is not going to come throwing just more data at it, but throwing more context at it, fine tuning it, setting experiments and optimizing it.
Okay, got it. So I'm sure any data scientist goes this will have a treasure trove of learning from this conversation, Mathangi. But as a last question, if you had to give three advices to any aspiring data scientist or a young data scientist who's just starting off her or his career, what would it be?
So one, data is about two things, data and sciences, right? So you got to have your mathematical foundational knowledge deep, but you also need to understand data. And for that, you need to understand business context, right? So understanding data, understanding context, being at the same time very deep in science, the mathematics of it is extremely important. And once they get into the grind of a job, and then they start cracking problems, watching out for impacts, watching out the fact that they can make a difference to their immediate world around them, and hence to the world bigger around them, it becomes should become their driving factor, right? So one of the things that I kind of have realized possibly later than earlier is that your choice is to choose the purpose. Once you choose the purpose, then the purpose kind of guides you in your life. So the bigger purpose you choose, the larger and magnanimous you will be as a person. And the smaller purpose you choose will kind of take you there. So data can really, really make large impact, right? And those who are taking up this field, if they choose the purpose of making impacts through their work in data, that's a large purpose to choose. And once they choose the purpose, that will become larger and that will become impactful, they can make really a difference to lives of millions and billions of people. So even as the data scientists find their rope and find their kind of fitting to this world of data, what is also more important is kind of making their purpose meaningful, making their purpose to make a difference, not making their purpose about learning for algorithms and writing few research papers. Those are all kind of consequences to it. And the goal and the purpose has to be to make a difference to people around them.
Okay, very nicely articulated. Just one clarification I want. When you say purpose, are you referring in a philosophical sense, or purpose is like, the level of impact you can create in an organization?
I am talking about purpose as purpose of work, right? Purpose of
Okay.
professional life, right? So the sense of purpose that your profession can provide is the purpose you choose, right? Because you're spending maximum hours of your day in that. You are at it, you're passionate about it, and you may be passionate about it for the right purpose, and hence you can make a difference. Because a lot of people come into the field for different reasons. They kind of come into the field for making more money, or coming to the field of having a cool job in the 21st century. So those are not the purpose, right?
Okay.
Or working in a cool place, right? Or I want to come to this field because I can have work life balance. Those are not purpose. The purpose is what you can do to the world because you chose that field, and it's a great field to make that difference. So come in for that and be attached to that.
Okay. Very nicely articulated, Mathangi. It's been a pleasure. I think just about slightly over 1 hour. I could keep continuing the conversation and really enjoyed listening to you and learning from you. Thanks once again for making time and talking to us at Expert Talks at Mavericks.
Thanks, Maha. It's been a really lovely conversation. I kind of thoroughly enjoyed it. You
Thank you.
touched upon a lot of topics very, very close to my heart, and some of my observations over the years, some things that I constantly reflect in my mind and have a very definite viewpoints on these. So, and these conversations kind of also help me to think better and some way make me also a better person. So, thanks a lot for that.
Thank you, Mathangi.
Thanks. Thank you. Bye.